Now, here is the rewritten TTS-ready script.
Okay, let's unpack this. So imagine you're looking at two things that seem, well, totally unrelated.
Hmm.
On one hand, you've got complex math, right? Specifically calculus, like the idea of derivatives.
Right, the tricky stuff.
Yeah. And on the other hand, farming, like actual cows out in a field.
Doesn't seem like they'd mix.
How could those possibly connect? It seems kind of strange.
It's a connection that surprises a lot of people, actually, but turns out to be pretty powerful.
Right. And that's really what this deep dive is all about today. We've been looking at a source that bridges this exact gap. It shows how something as, precise and maybe theoretical as differentiation can be used to understand something as practical as, like, the daily weight gain in cattle.
It's basically taking a mathematical tool, one we usually use for abstract systems, rates of change,
Okay.
and applying it to a very biological, very economic process right there on the farm.
Exactly. So whether you're maybe trying to wrap your head around derivatives for the first time or maybe reviewing them for a class,
We're just curious.
or you're just, endlessly curious about where math pops up in unexpected places, our mission here is really to show you how this calculus concept isn't just for textbooks.
Not at all.
It's a tool. It provides real insights in fields like agriculture. We're going to see how it helps, optimize how cattle grow.
Okay, think about it like this.
Yeah.
If you're tracking a group of calves, right, you weigh them periodically.
Sure, maybe once a week or something.
Yeah, once a week, once a month, whatever it is. You get a chart, basically, of their total weight over time.
Right.
Let's call that function WT. W is the weight, and T is the time, let's say in days.
Okay, WT. That makes sense. I can picture the weight going up over time. Plot a curve on a graph.
Exactly.
But that only tells me the total gain over that whole period, right? It doesn't really tell me if they were gaining weight super fast, like last Tuesday, or if maybe their growth slowed down a lot after you changed their feed a couple of weeks back. How do we get from that total weight line to understanding the speed of growth on any particular day?
And that right there is precisely where the derivative comes in.
Ah, okay.
The derivative of that weight function, which we write as WT,
3 gram T, got it.
that gives you the instantaneous rate of change of weight with respect to time. So while WT is the total weight at time T,
Yeah.
WT tells you how many pounds or kilograms, whatever, the animal is gaining right at that moment. Or you can think of it as on that specific day. It's their daily growth speed.
Ah, the growth speed. Okay, so instead of just the total distance traveled, like in a car,
Yeah, good analogy.
we're looking at the speedometer reading at any point in time. That completely shifts your perspective, doesn't it?
It really does. And our source material, it specifically looks at cattle that are raised on various agricultural crop residues.
Okay, what kind of residues are we talking about?
Things like corn stalks, straw, the stuff left over after you harvest the main crop.
Right, the less nutrient-dense parts.
Exactly. They're often cost-effective feeds, which is
Right.
great, but their nutritional value and their impact on growth can vary quite a bit.
And just looking at the total weight gain might not give you the whole story
Precisely.
about which residue diet is truly the best one or how the cattle are actually responding over the whole feeding period.
You got it. By calculating the derivative, that WT, for different groups of cattle on these different residue-based diets,
Okay.
the researchers, they can actually see the pattern of daily gain. They can compare it not just the final weight after, say, 90 days.
Which is what you might normally do.
Right, but they can see how the rate of gain changed day by day, comparing diet A versus diet B, for instance.
Okay, and here's where it gets really interesting and valuable, I think. Our source suggests that just comparing that total gain might miss some really crucial dynamics. For example, maybe cattle on diet A show a higher peak daily gain, right? Their WT spike, say, day 50.
A big spurt early on.
Yeah, but then maybe their growth rate kind of slows down later in the period.
Well, contrast that with cattle on diet B. Maybe they're fed a different residue mix. They might show more consistent, steadier daily gain throughout the whole time. Even if their peak WT, their top speed, isn't quite as high as diet A's peak.
Huh. So you could actually have two groups finishing at roughly the same total weight after 100 days.
Yeah, it could happen.
But the path they took to get there was totally different because their rates of gain, their WV curves, looked different along the way.
And for a farmer or a nutritionist, that distinction is, well, it's critical.
Why is that?
Well, a diet with that rapid early gain, like diet A, it might get animals to market weight faster,
Oh, right.
which could potentially save on feed costs over the long run, even if the total final gain isn't dramatically higher.
Oh.
Or maybe that diet with the steady, consistent gain, like Diet B, that might indicate better overall health, or maybe better feed conversion efficiency throughout the entire growth cycle.
So it gives you a much more granular understanding. It goes beyond just the final outcome.
Exactly.
You can see if a particular feed ration is supporting strong growth consistently, or maybe if its effectiveness kind of tapers off after a while. And this insight, which comes from looking at the rate of change, the derivative, it allows for much more informed decisions about which feed is best.
Right.
Not just economically, maybe, but also for really optimizing the animal's performance and maybe even its well-being.
It basically transforms weight data from just being, a simple progress report
Yeah, check mark, they gain weight.
into a really detailed performance analysis tool. It's much more powerful.
So, okay, wrapping up this deep dive then, we've seen how applying calculus, specifically using the derivative of a weight function,
That W.
gives us the rate of daily weight gain in cattle. And that offers really key insights into how effective different diets are, like those using crop residues.
And this, I think, really clearly shows how these concepts you might be learning about in a math class.
Yeah, things that seem abstract.
They can actually leap off the page and provide real, quantifiable value in very practical, sort of everyday fields like agriculture.
What really stands out for me, is how seemingly simple measurements, like just weighing an animal,
Yes, basic stuff.
they become these incredibly powerful data points when you start looking at their rate of change. So if understanding the speed of weight gain can help optimize something as fundamental as raising cattle, it makes you wonder, right? Think about the other processes you encounter daily.
All sorts of things.
What else out there might reveal some fascinating, maybe really useful insights if we just stopped looking only at the totals or the final outcomes and started paying attention to their rate of change, their speed?
It's a great question. Definitely something to ponder as you go about your day.